Welcome to another lesson on all about AI. In this lesson, we are going to cover about data preprocessing. Data preprocessing is one of the most vital part of any machine learning project. So if we compare with our analogy with oil and car, all collected data is like crude oil. In crude oil, it first goes through refinery, and then this refined oil is being used for car, Formula 1 car, different kind of vehicles, aircraft. So all of them have different need in terms of purity or goodness of the oil. Similarly, when we see the data, we have collect raw data from various sources. Once this data is being collected, it has to go through various pre-processing to remove various problem in data to make it usable for the algorithm. Now, different algorithm has different need. Just like the Formula 1 car, the quality of oil and the normal car quality of oil differs. Similarly, some of the algorithm requires very sophisticated pre-processed data, while some algorithm they inherently come with data pre-processing and data manipulations. Now we'll be covering various data pre-processing methods like data cleaning, data transformation, data encoding, data reduction, data scaling, data balancing, data discretization, data integration, data anonymization. Some of them will be specific to a few fields, like data augmentation will be used in image, text. Then there are specific pre-processing for text, image, and time series data. But even before we go into that details, we need to understand about the data. Basically, we need to know what we are going to pre-process or what we are going to correct. So first step is to examine various data types, its distribution, the basic underlying pattern in the data. So first step is to understand this data, which is done usually through a lot of exploration. This process is called EDA, Exploratory Data Analysis. Once the problems or potential issues are identified, then only we'll go into data pre-processing steps. So before we jump into understanding data, it's important that we understand various types of data. There are numeric data, which comes in two flavor, discrete and continuous. Number of student in class, number of car one would have, number of room in a house. All these are like discrete number. Continuous number like height of a person, which could be like 150.6 centimeter, temperature, which could be say 34 degrees centigrade or 102 degree Fahrenheit, weight of a person, which could be say 60 kg. So all these are example of continuous data. Then we have very well-known data, binary data, which is only two possible values, either say 0 or 1, yes or no, on or off, good or bad, something like that. Then we have data for date. Now again, it comes in various formats, like it could be MMDD, YY, or it could be also with timestamps. So these are like various example of dates. There is another crucial category is categorical data. Categorical data comes in two flavors, nominal data and ordinal data. When data has no hierarchy or sequence or pattern, then it's a nominal data, like say gender, male, female, colors, red, green, blue. There is no order in the data. Types of animals, dog, cat, bird. But when this categorical data has some order, say ranking, first, second, third, educational levels, higher school, bachelor's, master's, customer satisfaction ratings, satisfied, neutral, dissatisfied, all these have order. So they are called ordinal data. Then we have text data. So text data, there are various forms of text data: email, social media post, news article, books, product reviews, legal documents, contracts. So there are various kinds of text data. Next, we have specific category of data like image data, photographs, medical images, satellite images, X-rays, MRIs, different kind of image data. Then we have time series data, like various stock exchange data, seasonal data, like companies' profit and loss happening over the years. Next, we have audio data. So various audio source, like even this YouTube video has audio data from music, conversation, presentation. So all these are audio data. Video data. Of course, YouTube is a great source of video, and there are a lot of video data available everywhere. So data from drone, various source of video data. Other than these, there are many other sources of data like geospatial data, the graph data, like social network has the graph data, sensor data, various sensor collecting temperature, like sensor data in cars, sensor data from IoT devices, biometric data like fingerprints, retina scan. So all these are biometric data. We have genomic data. Then 3D data. So as you can see, there are many different types of data, and the processing for all these are different, and some of them require sophisticated processing to convert them to the data that algorithm would like to have. Now, we are familiar with all these data type. The next important thing that we should know about is the exploratory data analysis. This is the very first step. Once data is being collected, we need to go through the data and understand about the data, like some basic statistics of the data. We also use various graphical method to understand about the data, different charts. We'll be using Titanic dataset as a sample example to explain the basic concept around EDA. So we are loading Titanic dataset here, and then basic information check. So you see there are 891 entries, and we can see there are 177 entries missing for age. Cabin, a large number of elements are missing, and those are like missing value handling candidates. Usually we will do a lot of analysis of data to find out more about what it contains, what are the different values, how it behaves. So in this case, we'll do basic statistics and distribution. Some of the fields like age distribution, fair distribution, mostly histogram, count plot, those we'll be doing. Say this is the age distribution, fair distribution, survival count, passenger class distribution. So you can see the class, all these classes are not equally balanced. Port of embarkation, gender distribution. Then we will also do bivariate analysis, bar plot between various fields like sex and survive, and also like pair plot, correlation metrics between various data elements. So this is like a pair plot. Here you can see like how the data relation between two variables are depicted here. The correlation between various fields. Then survival agent count, like for survival rate by fair. So that's how typically the EDA is done at very basic level. There are a lot of sophisticated approach followed for vision, text, all those cases. There are many more ways to do it, and we'll cover them in very detail when we'll go through some of the data elements, particularly in our AI Advanced and AI Wizards lessons. Next step is fixing data issues. So at this stage, after exploratory data analysis, we have found out all the issues or things that we need to address as part of pre-processing. First, we'll start with data cleaning process. There are 4 key areas of handling data cleaning: handling missing values, removing duplicates, outlier handling, correcting inconsistencies. Now, handling missing values. How you handle missing values? One way is to impute missing values through statistical data like mean, median, mode. Another way could be to remove the row or column if there are excessive missing values. Third way could be use specific algorithms that handle missing values natively. As I mentioned earlier, some algorithm can handle some of the data deficiencies inherently. Next thing we need to do is removing duplicates. If there is any duplicate, we need to handle. Now, one way could be simply remove all, but one instance of the duplicate data is retained. Question is which one we should retain. Most of the times, it could be the first one or the last one among the duplicates. For specific cases, one might have to use aggregating the duplicate data points. In very rare case, domain knowledge is used to keep specific duplicate data. Next step is outlier handling. So in our outlier handling, we will detect outliers using statistical methods like Z-score, IQR, interquartile range, or some kind of plot like box plot or scatter plot, etc. We may also use model like isolation forest, DBScan, one class SVM clustering, which help to find the outlier. There are few mechanisms like capping flooring method like winsorization. So this limits the extreme values in the data to reduce the effect of outlier. It basically replaces the extreme value with specified percentile value. There are also mechanisms like replacing outlier with substitution, such as a mean, median, or some predicted value based on other features. Now, it's very important to understand some kind of machine learning. The purpose of that machine learning algorithm is to detect outliers, like anomaly detection, fraud detection. In those cases, the objective of algorithm is to detect outlier. We are not talking about those algorithms here. We are talking about in normal data or data for a purpose where we are trying to do some prediction, and their data has some abnormality or outlier, could be because of various reasons. It could be data entry error or something malfunctioning, because of which, and if we don't fix it, it could skew the algorithm output. That's the whole purpose of handling outlier, and we'll go in detail in our advanced lesson. Next thing is to correcting inconsistencies. There could be inconsistency in various ways, like dates, address, phone numbers. They can have different formats across different datasets, or even if we are merging different datasets from different sources, they can have differences in terms of formats. Just like a simple one, date could have MMDDYY format in one dataset, or in one field. In another field, it could be DDMMYY. So we need to make all this data consistent. Also, it is required to implement rule check to validate the entries are legitimate entries. Say age. We know the age cannot be less than 0, or it cannot be, say, more than 120. So if something is beyond that, we should have a mechanism to fix it. String matching and fuzzy matching. In many cases, the data would sound similar, or people will be entering the data in a similar way. Just like, say, in the case of name, like New York could have a New York City. There could be abbreviation like NYC. So we need mechanism to bring them all together to make a standardized form. Also, some cases, industry-specific and domain-specific knowledge is required to correct inconsistencies. Say, in medical domain, correcting medical codes based on standard classifications. So if there is an error, you can correct it by classifying based on other data element. Now, These are the main ideas behind data cleaning and how it is being done. We'll be covering them with detailed Python code and different methods in our AI advanced lesson section. So data transformation and data scaling. I'll be combining both together because they are quite similar in nature and it's being used interchangeably in many places. So what are the data transformation and scaling methods available? We have normalization, standardization, min-max scaling, robust scaling, log transformation, box-cox transformation. These are the very well-known data transformation and scaling methodologies. Now we will use a simple analogy to explain why data transformation or scaling is required. Here we have used a simple data table with orange, apple, banana, grape, their weights and corresponding price. Now, what algorithms in AI and MLCs are these numbers only, and they don't understand the difference between weight and price. Since weights have larger number here, this algorithm treat it's more important compared to price. So feature scaling is needed to bring every feature in the same footing without any upfront importance. Not every algorithm requires the scaling and transformation. Mostly those algorithms which are distance based like KNN, K-means, PCA, and even neural network, it has been seen if we use scaling, then it performs much better. Usually, if algorithms are rule based like cart, random forest, mainly the tree based algorithms, there we don't need any kind of data transformation or normalization or standardization or any kind of scaling because algorithm itself is able to handle it. Now, what is normalization and what is standardization? Normalization is used when we want to bound our values between two numbers. Though typically it's between 0 and 1 or -1 and 1, you can still set two different values, say 0 and 10. This is basically scaling all the numbers between this range. Compared to this, standardization is transforming the data to have a mean 0 and a variance of 1. Basically converting it into a normalized form. Now, both of these makes the features unitless. So which means if we are comparing between multiple features, after we apply them, all these features become unitless. It doesn't matter whether it's a kg or gram or milligram, it will convert such a way that from algorithm point of view, all are similar. Now, let's understand how it looks like if we plot data. Suppose all this data in first quadrant, somewhere positive between 1 to 10 in x-axis and 1 to 10 in y-axis. And if we normalize the data between 0 and 1, how it will look like this, the box, rectangular box within that yellow, what you see here, like this will convert into this green. That's what normalization is doing. Now come to standardization. You can see because it's making the data mean 0, so data will be spread across this space, which may be positive, negative, but ultimately variance will be 1 and the mean will be 0. Let's look into other scaling method. Min-max scaler. This transforms the feature by a given range, say 0 to 5. But only thing is it's very sensitive to outliers. Robust scaling. This scales features using statistics that are robust to outliers, which means it's primarily using median or interquartile range to scale the data. And usually this is being used when there are many outliers. Next, we'll talk about log transformation. So in this case, we apply logarithmic function to compress the range and reduce the skewness. Usually used for positive skewed data. Box-Cox transformation. This transforms data to follow a more normal distribution using a power transformation. This is often used to normalize and stabilize the variance in data. So we'll go through all of them in more details in our AI advanced lesson with the corresponding Python code. Other than these methods, there are also few other scaling and transformation methods like unit vector scaling, max F scalar, quantile transformation, power transformation. So all these things we'll be covering in our advanced AI lessons. So with that, we'll move to data encoding. So there are various methods available in data encoding. These are the most commonly used one hot encoding, level encoding, ordinal encoding, binary encoding, frequency encoding, target encoding, hash encoding. Why do we need categorical variable encoding? If you remember, there are two types of categorical variables. One is nominal, where there is no particular order, just like the example here, pen, pencil, eraser, or cow, dog, cat. None of them have any specific order. And the other category of categorical variables are ordinal variable because they have some kind of order in it. Say, when we say excellent, good, bad, or fantastic, okay, don't like, all these emoji or responses, they have a sequence or order. So categorical variable encoding uses nominal and ordinal concept while constructing the methods. Algorithms in machine learning and AI, they cannot handle categorical variable unless they are converted to some kind of numerical values. And it has been seen many algorithm performance improves dramatically after they are encoded. For our discussion purpose, we'll be using a toy example with 10 data points containing features like temperature, color, and target. So temperatures are like hot, very hot, warm, and cold. And there are only three colors: red, yellow, blue. So first we'll start with one hot encoding. In one hot encoding, we convert each category value into a new column and assign a value either 1 or 0. It's a very popular method. If you just take the temperature example, here for temperature, there are 4 values. So it will create 4 columns or 4 categories like cold, hot, very hot, and warm. And it will turn on if that variable is present in that data point, right? In the first case, it was hot, so hot was turned on. In the last case, data point was cold, so the cold is turned on. Next, we'll look at level encoding. In level encoding, it assigns a unique integer to each category. It's more suitable for ordinal categorical variable. And as we have seen, when there is a meaningful order, we can use this level encoding. So in this case, hot, cold, very hot, warm, there is a gradual sequence and order. So we can use that to do level encoding. Then we have ordinal encoding. Like level encoding, it's also particularly meant for ordinal variables, but it assigns integer values. So this is used where order is very important. Binary encoding. Binary encoding converts a category into binary digits. With each binary digits, it creates one feature column. And it's very useful when there are many categories, but we want to convert them into relatively smaller number of features. It's usually much less number of new columns compared to one hot encoding. So if we convert the temperature, so if you see the temperature variable, it's converted into its equivalent binary form. So here there are 3 bits and 3 bits being converted into 3 different columns. And when there is 1 in that bit related column, those fields are turned on. So specifically, if it is very hot, it's 0, 1, 1. So if you see both the column 1 and 2, both were marked as 1 and 1. Next, we have frequency encoding. So in this case, each categorical variable is replaced by its frequency in the dataset. So here you can see we have converted this data into frequency encoding. It's very useful when frequency of categories carries predictive power. So in this case, since there are 10 variables, hot happened 4 times here, 1, 2, 3, 4. So 4 divided by 10. So it's 40% times it's happening. So it's 0.4. Similarly, all these are calculated. Target encoding. This is one of the very popular encoding. Few years back, it used to be the go-to encoding in Kaggle competition. There are few varieties of target encoding. Here we are talking about mean encoding. So it replaces each category with mean of the target variable for that category. So if you see, we are talking about temperature and here is the target. In first step, what is the sum of the target for each category? So cold, it was 1 in 2 case. So one from here and 1 from here. So this is 2, 3, 1, 1. And what is the count of the target? So cold happened how many times? Total here 1, 2, correct? Hot happened 4 times. 1, 2, 3, 4. So count is 4. But again you see hot, it was sum of target was only 3 because 1 was turned off. So this was turned off. So once we calculate this, the next step is basically finding the mean. Divide this by this, it will give the mean. And that's how we convert this into target encoding. Any high cardinality categorical variables with a strong relationship to the target variable, this encoding is preferred. Next is hash encoding. In hash encoding, we apply hash function to categories and use the hash values as the features. Suitable for high cardinal features to reduce the dimensionality. You can even restrict the number of columns that we want to set. You can use hash encoding when the cardinality is very high. So we just scratched the surface here. There are many more methods and many of the state-of-the-art categorical encoding methods we'll be covering in our detailed AI advanced lessons for AI practitioners. There are more than 25 methods. We'll go through code, example, and also run toy example and see how different algorithm performs against some of these categorical encoding. And we'll do some benchmarking and comparison between them. Stay tuned for AI advanced lessons. Next, we will take a look at data reduction. There are various methods in data reduction like feature selection, dimensionality reduction, instance selection, aggregation, data compression. So why do we need data reduction? First thing is computational efficiency. Once you reduce the number of data variables, if there are many features, then your computational efficiency improves a lot. Other thing is data storage. If there are too many features and you have a lot of data, sometimes you want to keep only those important features, and those which are not relevant you may want to discard. So that's how the data reduction comes into picture. We have seen after data reduction, for many algorithms, performance improves a lot because of data reduction, remove the noise and irrelevant information. It's an essential, important step in machine learning to simplify data while preserving key information. Mostly in high dimensional data space, it can improve efficiency. Now let's take a look at various data reduction methods. Feature selection. This involves identifying and retaining only the most relevant features. So what are the methods available within feature selection? There is something called filter method. This uses statistical techniques to evaluate the importance of each feature, Pearson correlation, chi-squares test, mutual information. All these are examples of filter method. Another way to do feature selection is called wrapper method. In wrapper method, we use a predictive model to evaluate the combination of features and select the best subset. Another method is embedded method. In this embedded method, we perform feature selection as part of model training process using some methods like regularization, say lasso, or tree-based methods like random forest. Next, we have dimensionality reduction. Here, we create new lower dimensional features from the original ones. Some of the most popular dimensionality reduction methods are principal component analysis, also called PCA. PCA is a linear technique that transforms data to a lower dimension space by finding the directions that maximize the variance. Linear discriminant analysis, LDA. That is also another popular dimensionality reduction method. It used a supervised linear technique that projects data onto a lower dimensional space by maximizing separation between different classes. T-distributed stochastic neighbor embedding, or TSNE. This is also another very popular. Similarly, there is uniform manifold approximation and projection, UMAP. All these methods also used for visualization to separate data and also find the most important features in a data set. TSNE and UMAP are nonlinear technique. They are heavily used in visualization, preserving both local and global structure of the data. Next, we have instance selection. It's selecting a subset of instances, data points that are most representative of original data. So far we have seen how to reduce the features. Here we are talking about the data points itself. And mostly these are example of sampling methods. So we can do random sampling, stratified sampling. Stratified sampling ensures the sample subset maintains the same class distribution as the original data set. So for classification scenarios, stratified sampling is used because it preserves the distribution among different categories. Cluster sampling. So in this case, it divides the data into cluster and randomly selects clusters to create a subset. Aggregation. In aggregation, we have data binning and clustering based reduction. Then we have data compression. Data compression, we have lossless compression and lossy compression. So lossless compression, it's like removing information, but it can be again reconstructed fully. Example is like JPEG for image or MP3 for audio. But in case of lossy compression, we cannot reconstruct the data once it is compressed. Data balancing. So data balancing happens when there is an imbalance in the dataset for the target classes.
Typically, we see dataset with rare events have data imbalance. Like in case of medical dataset on cancer, only a small percentage of people are diagnosed with cancer. Same is fraud data in case of credit card transaction dataset.
Now what happens is this imbalance often leads to bias, and algorithm cannot process the minority classes properly. So there are various methods to address this data imbalance. Some of them are oversampling, undersampling, hybrid methods, ensemble methods, algorithm level methods, class weight adjustments.
First, we'll take a look at oversampling method. In this case, we can balance dataset by generating new synthetic data or duplicating existing ones.
Like we'll be sampling multiple times, and often after that both the classes will have almost similar
distribution of classes in the dataset with which model will be trained.
So if you see here smooth, which is a well-known process to synthetically generate data. So in this case, original data has imbalance because of majority class has more data compared to the minority class. So what we'll do, we'll be generating synthetic data using some mechanism, and those data will be used in the final algorithm training.
Another method is undersampling.
So in this case, we will be selecting some sample from majority class, and using that, the algorithm will be trained. So if you go by the similar example, the original data set,
we'll take few samples from majority class.
And for minority class, we'll take it as it is.
After this undersampling, dataset will have balanced data points with which the model will be trained.
The next way to do it is hybrid methods. In hybrid methods, we will increase the minority class, and at the same time, we will also decrease the majority class. We can use smooth plus edited nearest neighbor or smooth plus stomach links. Another way to do it is ensemble method. In this method, we will be using ensemble technique like bagging or boosting to combine with the sampling methods. Algorithm, balanced random forest, easy ensemble, and balance cascade. These are the methods part of ensemble methodology. These are a little bit advanced ensemble techniques where multiple balanced datasets are created using resampling, and the model is trained using these aggregated datasets. There is another way to handle sampling is cost-sensitive learning. So in this cost-sensitive learning, the higher cost is assigned to misclassification of the minority class. By assigning higher cost at the time of training, if it is misclassify the minority class. There is another way is class weight adjustment. So instead of changing the dataset, this approach modifies the learning algorithm such a way that it penalizes misclassification of the minority class more than the majority class. So there is a penalty that works in this case.
Now question is, when we should use all these techniques during the pre-processing step to balance the dataset?
So if you see there is a significant class imbalance, then you should use it. Particularly if it is a binary classification and if one class is underrepresented, there is a best case to use these methods. Also, when matrices like F1 score, precision, or recall are crucial, then we should use one of these methods to balance the dataset. But do note, there is always a risk of overfitting if we use
oversampling technique.
some models handle imbalance inherently.
We also need to be careful about data volume, as balancing can increase the data size.
And it's important that we should use metrics beyond accuracy if the classes are imbalanced. Next, we'll look into data discretization. Now, in data discretization, the purpose is to transform the continuous data into discrete intervals. So, if you see here, there are a lot of data, and we can convert them into some discrete interval levels. In certain dataset and certain algorithms cases, it improves the model performance. It also simplifies the models, improve the interpretability. It does noise reduction. Sometimes it handles outliers very efficiently. And it also improves computational efficiency. Now we'll take a look into various discretization methods. One of the very popular one is equal width discretization. It divides the range into equal width intervals. Simple, but may result in uneven data distribution. Equal frequency discretization. This is done by creating equal number of data points. This ensures well populated intervals. K means discretization. This uses clustering to create intervals. Decision tree based discretization. This uses algorithms like CART for splitting data optimally. Since this is a supervised method, it can be computationally quite expensive. Next, there are entropy-based discretization, which uses information gain to determine boundaries. Effective for classification task. Chi-square based discretization merges interval based on chi-square statistic. Binning by rank. This is also called quantile binning. This creates intervals based on percentiles. This ensures the data is distributed uniformly. There are a few other methods like minimum description length principle, Jenks natural breaks, and there are also few domain-specific methods. Now, when to use discretization? If algorithm requires categorical input, sometimes to improve model performance and to reduce noise, and also to increase interpretability, this is often used. But it's important to note, it's not always necessary. Sometimes it leads to information loss. It can have an impact on specific dataset and model while evaluation. Next, we'll take a look at data integration. Data integration is the process of combining data from different sources into a unified dataset to improve analysis and model training in machine learning. It ensures consistency. Sometimes it's enhanced data quality. Also, different sources make data more diverse. And also, comprehensive and accuracy can be improved by combining multiple sources. Ultimately, it is for quality, quantity, and diversity that improves the model performance. Now, if we take a look, there are a few ways of doing integration. Some integrations are feature level. So it could be like feature concatenation, while combining multiple features from different sources into a single feature vector. Feature fusion, combining features using weighted sums or more complex function. Multi-view learning, training separate models on different feature sets and combining their outputs. There is also model level integration possible, like ensemble methods, where combining predictions from multiple models, like we have seen boosting, bagging, stacking, etc. These are example of model level integration. Transfer learning is another area which is getting very popular nowadays, and this uses knowledge from one domain to another domain. So in this case, is the learning from one domain is used to improve performance in another one. Another method is called federated learning, where the training done across decentralized devices
or servers without exchanging raw data, and later they are combined together. There is also data level integration. Like we know about data warehousing, data lakes, ETL process where data is aggregated, extracted, transformed, and loaded from various sources. There is also semantic integration where using ontologies and knowledge graphs to align data from diverse domains. Now the question is when to use data integration. When data is scattered across different systems or database, then we should use data integration. Also, if we see incomplete data, to fill the gaps, combining related datasets is useful. In certain complex analysis, we require data from various domains and also from different perspectives. Important note, when using this preprocessing method, we have to ensure that data quality from different sources is consistent. There is a compatibility between different data sources in terms of formats, schemas, data structures. Sometimes scalability is one concern due to time and storage constraint. Privacy and security is paramount in today's world where protecting sensitive information during the integration process is important to take note of. Next, we'll take a look at data anonymization. Data anonymization is the process of transforming personal or sensitive data so that individuals' privacy is protected while using the data for machine learning models. So if you see in this example, the name of a person is converted into some number and letters combination, which is difficult to find out just looking at that anonymized data. So purpose of data anonymization is to preserve the privacy, enabling valuable data used for training models. Also, sometimes it's due to protection and conforming to the regulations like GDPR, HIPAA, enabling data sharing collaboration in ML projects. It is quite important in sectors like healthcare and finance where sensitive data is prevalent. It allows organizations to leverage large datasets for robust ML without compromising individual privacy rights. Now, there are various ways to do anonymization. Data masking is one of them, which replaces sensitive data with realistic fake data. For example, substituting real name with fictitious name. Pseudonymization, replacing identifiers with pseudonym. This allows re-identification if necessary. Data generalization, here replacing specific values with broader categories. Converting exact age to age ranges. K-anonymity, ensuring each record is indistinguishable from at least K-1 other records. It protects individual identities while allowing more meaningful analysis. Another way is differential privacy, adding statistical noise to data or query. This ensures inclusion and exclusion of a single data point doesn't significantly affect the outcome. Data perturbation. This is the way where a little bit noise is added to numerical data to obscure the individual values. It ensures the overall statistical properties are retained. Diversity, ensuring sensitive attributes have diverse values within each group of anonymous records. Enhances privacy protection against inter-inference attacks. Synthetic data generation. Certain areas creating artificial data that mimics the statistical properties of the original dataset. Now, when to use? Mostly, it is required to handle sensitive personal information, as we have seen for healthcare, financial data. When data need to be shared with third parties or public dataset, it is also required to complying with privacy regulation, protecting sensitive information in ML research and development. There is always a balance needed between privacy and utility of data. There is no perfect anonymization method. It's always required to reassess. Consider combining multiple techniques for stronger protection. It's recommended to regularly review and update anonymization strategies as machine learning techniques are ever evolving. There is always a potential bias introduced and performance impact due to anonymization. Ongoing assessment of anonymization method is critical as advanced techniques may lead to re-identification. Now, we'll quickly go through remaining 4 categories: data augmentation, text preprocessing, image preprocessing, time series preprocessing. So, for data augmentation, in data augmentation, we artificially expand the size of training dataset by creating modified versions of existing data. Usually, this technique is predominantly used in image, text, and audio. In image augmentation, we use like rotation, flipping, scaling, and adding noise to image. For text augmentation, it's replacing synonym, random insertion, or back translation to generate new text samples. For audio augmentation, we add background noise, time stretching, or pitch shifting. These are the methods used for audio augmentation. Now, what is the benefit of having data augmentation? Reduce overfitting by exposing model to various additional data. It also improves model robustness and accuracy. And especially when there is a limited data, data augmentation helps us to create more data to train the model effectively. This is widely used in computer vision, natural language processing, and speech recognition tasks. Next, we'll look into text preprocessing. So, text preprocessing involves transforming raw text into clean and structured format suitable for machine learning models. There are various methods involved, like tokenization, where splitting text into individual words or tokens, lowercasing, converting all characters to lowercase to maintain consistency and uniformity. Stop words will be removed, like and, the, or. Stemming, lemmatization, reducing words to their root form, like running will become run. Vectorization. Many algorithms require converting text into numerical representation, like TF-IDF, word to vector, etc. Text preprocessing enhances the quality of data and it leads improvement in model performance, is very useful in sentiment analysis, text classification, and many more. In fact, in all chatbots like ChatGPT, Gemini, all are using many sophisticated text preprocessing. Next, we'll take a look at image preprocessing. In image preprocessing, the raw image data is converted into suitable format that machine learning model can understand. This step is crucial to improve model accuracy and performance. Key techniques are rescaling, where we adjust the pixel values, typically normalized within a range. Resizing, alter the dimension of image to ensure consistent input for the model. Data augmentation, as we have seen already, that various techniques for augmenting data is being used for image. Denoising, remove noise from image using filters like Gaussian or median. Histogram equalization improves contrast by redistributing the intensity value of the image. Now, preprocessing for image ensures the optimal format for training, leading to better model performance and generalization. Next, we will look at time series preprocessing. In time series preprocessing, which is a little bit unique compared to all other processing, there are different things being done to ensure data is processed correctly. And lag feature engineering, create lag feature to capture temporal relationship with previous timestamp. Differencing, apply differencing to remove trends and make the series stationary. So differencing ensure there is no relationship between two data points. Rolling window calculations, use rolling windows to compute moving averages, standard deviation, etc. for smoothing and pattern detection. Seasonal decomposition, decompose the series into trend, seasonal, and residual components to isolate patterns. Resampling, adjust the frequency of data points, like from minutes to hours or seconds to minutes, to match the analysis needs. Also, there are various time zones being used So it's important to normalize those time zone specific data into a standard time zone to ensure consistency.
That's all for this video. Thanks for watching. Don't forget to like, share and subscribe for more exciting content on machine learning and AI.